What I want to do is talk about what I'm calling indexing the unknown. Am I loud enough? Yeah,
I think so.
thank you. So this has to, I called this something about block diagrams, and that sounded awfully boring. But what I want to have is a block diagram that shows the thing that's missing right between this part and this part. And that's a hard block diagram. If you ask any team, draw a block diagram of your system, they'll draw a block diagram. And you ask this team to draw a block diagram, they'll draw a block diagram. By the way, they won't use the same diagramming tools, strangely enough. But what I've done and want to improve how we do is make diagrams that capture the space between the software that we write. And that's because that's the part that's going to act up when you deploy this stuff at scale and you get a call in the middle of the night. And it isn't going to be something wrong here or here. It'll be something wrong in between. There was a colleague of mine who called that finding the seams in software. That was his phrase. I said, I really think it's important to be able to read software. And I said, and he said, I really think it's important to not read software, to find the seam and see what's going on at the seam between software. And I took that seriously. And what I want to show you is how a diagram can highlight what is between the unknowns between the various parts of your program. So I had some motivation here. I mentioned, okay, that was asking the expert. So we want to talk about systems. I was hinting at systems. The one thing about, team A uses one drawing program, another uses different drawing. It turns out that most drawing programs have a model of the system with the nodes and the lines and whatever. And if you have two different drawing programs, you have two different models. Simple thing. Separate the model of the system from the drawing of the system. And that turns out to make it easy to pull a little bit of this and a little bit of that, put it together and see what's wrong right in the middle. And this is the kind of thing you do at 3 in the morning when you're trying to get back to sleep if you just get the system running again. So I also feel a little pressure to skip along here, so I think I will. I did this in Neo4j. I read 40 different sources. I produced over 500,000 relationships. It has a nice query language. I could write a query that says, how many this to how many that, draw me a picture of it, and it could draw the picture. And I was stunned that people didn't find that useful. And the reason they didn't find it useful, well, people I knew found it useful because they just asked me, could you write me the query that'll draw the picture I need? And I would do it for them. I send it over Slack. But people who said, I want that in my company, couldn't build the database because you had to build it all at once. You build the database and then you can use the database. And that was the mistake. So the thing I've realized, I called it the first innovation, separate the graph representation from the block diagram and generate diagrams based on merging together, find this diagram and that diagram, merge them together for the moment to highlight the seam between the software. Second innovation was every piece of software does a half a dozen things. Don't put all of them on the same diagram. And the example I want to show you here is a search engine. And a search engine has a crawler and it goes through a bunch of web pages. In my case, I wrote one for Federated Wiki. It's pretty easy to search Federated Wiki, but when you get about 3,000 sites, it's complicated. I wrote one 6 years ago. It just got complicated. People said, where's my site? You're not indexing my site. I couldn't understand my own code from 6 years before. So I said, that's my model. That's if I can understand how to show that, then I'll make something that I can generalize and do the kind of work I did when I was a full-time employee. All right, so the graphs proliferate. So every, say you got 100 different kinds of pieces of software, everything that does 6 things, that's 600 graphs. Okay, computer's not going to have any trouble holding 600, but how do you find the ones you want? And that is, you bring up a graph, you say, this is what I'm working on, I want to make sure it's not my problem. And it says, well, this hooks to 3 other graphs, so let's put those there. Oh, this one hooks to 2 more graphs, let's put those there. This is like shopping in Amazon. It's a recommender system. If you think this is interesting, look over here. And that's easy to do as long as you're clear about what the different, well, if it's a search engine, you have the indexing part and you have the query part. In our case, we also had a status part and a debug part, 4 different aspects. And so it's 4 different graphs. The other thing you do is you have to continually discover this. It turns out that systems are a moving target, and it's in the middle of the night that you find the bug and you fix it and you go back to sleep. The next day, you convene a retrospective and you say, what went wrong last night? How are we going to make sure it doesn't happen again? And this is where the leadership, which I'm thinking are the quality people, will say, okay, where in the diagram was that thing that caused the problem last night? We know it's there because it caused a problem. We didn't know it was there before last night, but where would it be on the diagram? Oh, it'd be over here. It's not there. Would you mind if I put it there? QA person is going to draw system diagrams? Well, sure they will, because they're the one that just asked the question that is important. And the developers, they want to get out of the meeting and go on to their next deliverable. Put all that stuff, not on a diagram, but in a database in your repository, and then just file a pull request. Say, you told me yesterday this, I'm issuing it as a pull request. If you want to do it differently, you're a developer. But all you have to do is say accept, and it'll be there next time. This is the incremental process of discovering the unknowns that we're trying to index. Now, I want to show you this working. I want to show you, first of all, well, I think I'm just going to jump into how it looks to work. I thought I had a link here. I think I need the newer talk. I'll click newer. There we go. That looks more familiar. And GitHub. Hey, look at that guy. Hey, he's so young. All right, so you can find this. This is Ward Cunningham and GitHub, and it was the search engine I built. So if we click search, you'll notice that this has the usual sort of stuff like a readme.md, MD for markdown. It also has a readme.graph.json. That's the JSON for the graph of the whole search engine, all the different aspects of it. And it turns out that if you look at that, that was built by a graph action. Now, I didn't write that. That was that SVG, that graph, and the SVGs from it were built by the automation that we just put in the system. If you just annotate what's going on, it will build the diagrams. Let me just pop into the diagrams and look at it. Here they are. Is it working? Click. Come on. We'll click. Double click is the answer. So here it says, well, I said there's indexing and there's query. That's 2. There's debug and there's status. Let's look at indexing. That's the easy one. And here's a diagram. This was generated by GraphViz from the graph. And that's why we don't have to draw a graph. It keeps making them. If I go back, well, if I go back to where I was, and it says that was made by a graph action. If I click the graph action, It says, here's the diff. Everybody does this GitHub stuff, you know this? And of course, there's the file. We don't want to look at that. But here it says, oh, look at this. Now, it turns out, usually I see that side by side. On this computer, I see it on top. But they call this two separate. I can say, I want to swipe between the two diagrams. So this is the diagram that was the old diagram that's out of date. And I can just slide that over and see the new diagram. I mean, I didn't know that GraphViz did this. Not GraphViz. This is GitHub does this. And I'm told the other repos do this sort of stuff too. Here's one called Onion Skin. And what I'm trying to do is, did I update the information right? Fading in and out. That's pretty cool that they do that. And these are just flat files. But the especially interesting thing is, if I go back here, I have this thing called readme.html. This is an HTML script, nothing fancy, except that it can read JSON and it can draw a picture of it. And here's the little search interface, but down at the bottom it says, oh, launch the viewer. Remember, I produced 4 different diagrams for this. Now, you might have 40 different diagrams, but this viewer will still handle it. You launch the viewer and it comes up. Did it come up? That's not it. Double click. Click to go back. Previous tab, good. Thank you. So we'll click. There it goes. So this little viewer says, oh, you had 4 different diagrams. Remember we looked at index. There it is. And it says, oh, this connects with all these other ones, but let me just pull up query. And this says, okay, the query, if I turn this off, then I say just, there's query. Query talks to the query API. Look at this. This lights up the things that are on the seam between the 2 parts. They just light up. That's pretty neat. And it tells you, well, if you're looking at that, maybe you look at this stuff too. How about the debug logic? You know, and what we're doing is we're browsing. We're not browsing diagrams. We're browsing the seams between diagrams, and it lights it up. The thing is, you learn this incrementally. You update it in the roles that you have in your company. You collect it in a graph model that is JSON. It's JSON. It has nodes and it has relations. The graph people tell me that this is really important, that you, instead of discovering a relationship with some foreign key, you just say, I know that these are related. So you put the relationship in there, and that's the thing that you want to get to. So there's no guessing about it. You put the relation in there, it'll stay there. And that's what we're looking at here. I want to show you one more thing, and then I will shut up. And by the way, what I'm really trying to do is get you interested in this, because this is like a couple of months old. We had a, big power outage. I could have done some more, but I decided I would rather develop this as a capability that is industrial strength, not as a retired engineer fooling around in open source, but with people who actually have problems that could be solved by this, and will just tune it to solve your problems, and then figure out what else it has to do. But what I have is one more thing here. I think it is. Okay, I can't see it. I've misplaced it. What I really do is, all that was server side, I do the same thing with the client side. The client side has a bunch of different features. I was set up to kind of show you the features, but I know I'm getting in the way of the rest of our evening. I can pull information out of the client. I can pull information out of the server. I could say, well, in this case, we're not using that client. We're using this other client. They just come together. That's just one more seam in all this thing. And to see the picture where you can see the client that was exposing the problem. And I can call that up and see right there is where the problem was. And this 6-year-old software is like I wrote it yesterday. You know, it's really astounding. And the other thing is, if you've ever done anything with graph is you find that pretty soon your diagrams turn into spaghetti. And there's just lines everywhere. Even if you use a real good drawing tool, you know, if you're bothering to draw it, you want to get everything on there and it turns to spaghetti. The invention here is you only do one aspect of one set of software, and then you pull it together at the last minute, just the pieces you need to see what you're doing. It's like binoculars. You know, you just see what you want. And the only reason we haven't had this a long time ago is the people who do graphs write drawing programs, and they want you to use their drawing program, not this old GraphViz thing. But GraphViz is like magic. If you give it a drawing that it can draw a picture, it's small enough that it can fit on a page and look good. By the way, you can click things and say, oh, if I'm looking at this thing, why don't you show me the data rates on that thing? Well, hook it into all your other tools. Just click, click, click. It'll be magic. So let's do this together. That's the pitch. And I'm done. Thank you very much.